Let's look at the birthday problem. How many people do you need to have in a room in order to have a better than 50-50 chance that at least two of them have the same birthday? In other words, how many people do you need to have in a room so that the probability that at least two of them have the same birthday is greater than a half? The answer is 23 people. Let me show you why, and don't get hung up on the details. When you see at least in a probability problem, it's usually easier to find the probability that the opposite is true. And when we do this, we use the following principle. If A is an event, then the probability of not A is 1 minus the probability of A. In other words, the probability that A does not happen is 1 minus the probability of A. It's 1 minus the probability that A does happen. So the probability that we have at least two with the same birthday, that's 1 minus the probability that we don't have at least two with the same birthday. And if you don't have at least two with the same birthday, that means each person has a different birthday. So what we're calculating is the probability is 1 minus the probability each person has a different birthday. Okay, so let's find that. The probability that you have at least two people with the same birthday, it's 1 minus the probability that each person has a different birthday. Start with n equals 2 people in the room. 1 minus the probability that each person has a different birthday, well, let's say the first person has birthday December 1st. Then the probability that the second person has a birthday different than the first, that's just going to be the probability that the second person has a birthday on any date except December 1st. So 1 minus the probability that the second person has a birthday different from the first person, that's 1 minus 364 over 365, which is 0.003. So when you have two people, the probability that you have at least two people with the same birthday, that's just very small, 0.003. Now let's look at n equals 3. With n equals 3 people, let's find the probability that you have at least two with the same birthday. That's, in other words, the probability, 1 minus the probability each person has a different birthday. So first person has birthday, let's say, December 1st. Second person has birthday on any date except December 1st. And the third person has any birthday except December 1st and the second person's birthday. So 1 minus the probability that each person has a different birthday is going to be 1 minus the probability that the second has a birthday different from the first times times probability that the third has a birthday different from the first and second. That's, in other words, 1 minus 364 over 365 times 363 over 365, which is 0.008, significantly less than 0.5. So if you have three people, there's still a very small probability that you have at least two with the same birthday. Let's extend it to 4. If you want the probability that you have at least two with the same birthday, that's 1 minus the probability that each person has a different birthday. In other words, it's 1 minus the probability that the second has a birthday different from the first, times the probability that the third has a birthday different from the first and second, times the probability that the fourth has a birthday different from the first, second, and third. And that works out to be 0.016, still very small. Okay, so let's calculate the probability that you have at least two with the same birthday when you have 5 people, that's 0.027. When you have 6 people, the probability at least two have the same birthday is 0.04, still significantly smaller than 0.5. Okay, how about with 22 people? The probability that you have at least two with the same birthday is 0.476. If you have 23 people, the probability that at least two have the same birthday is 0.507. Ding, 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 ding. That's greater than a half. So how many people do you need to have in a room so that the probability that at least two of them have the same birthday is greater than 0.5? You need 23 people. And how can you remember 23? That's Michael Jordan's number. The best there ever was, the best there ever will be. Okay, you can shut off the video now, or you can watch my favorite Chicago Bulls play of all time, 1993 NBA playoffs, Bulls versus Knicks, Madison Square Garden, Game 5. Series is tied 2 games apiece. The New York Knicks have won 27 games in a row at Madison Square Garden. The Bulls in red are up by 1 point with 30 seconds left.
Ewing out to set a pick. Here's Staunch, changed his mind. Plenty of time on the shot clock, down to 10. Ewing for Smith. 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 Stop. Smith. Stopped again by Kiffin. What a play by Scott.
The man just could not buy a basket. He was in front of the basket, and he basically couldn't score, even on 4 attempts. Amazing. Amazing defense by the Bulls.